What is that? That's convolution. Right? That's convolution. What's that? That's convolution. Can it be the same thing, right? Convolution downsample by 2. Okay? If I call this is P of n. Okay? Well, what does it mean? It means that I have C of Z. How do I explain this? Okay. Let's define P of Z. It's C times C Z inverse. Okay? Can you tell me what does P of n look like? That's convolution, right? One would be flip of the other one. How do I write? Is it C of n, C of k, C of L, C of L minus n, right? What does P of 2n look like? C of L minus 2n. Okay? Okay. Okay. And 0, right? Minus 1, still 0. 2, minus 2, still 0, right? That's what I'm plotting Q of K right now. And that's just delta K. Okay? Let's map this because what you see here is this K is by factor of 2. So if you write this in the non-subsampling form, you will have 1 here, this will be 2, this will be 4, that's minus 2, that's minus 4. So basically, this is nothing but a half band condition. On P of Z. Okay, P of Z is like this. You only increase the index by 1. Comparing this one with this one, index increased by 2 because it in a different scale. Basically, we're saying that P of Z for every even index is 0. Okay? Equal to 0. This is basically a half band condition, right? And we don't care what is at 1 or minus 1 for P of K. Okay? At 3 and minus 3, and so on. So this is basically the half band condition on the product filter. This is your H naught, that's your F naught. If you recall how this H and F are related, I just split. Okay? So you see it here also. Let me think about another way to explain this. Next time. It's basically the equivalent condition of the normal on the matrix itself. It's basically a half band filter condition on this product filter. Questions? we will only talk about dyadic wavelet. Dyadic is for 2, based on 2. Okay, di is 2, right? Okay, so dyadic wavelet is when you have downsampling by 2, and so on. Wavelet is basically a cascade of filter bank. So we want to have low pass, power by 2, high pass, power by 2. We're going to cascade this on the low frequency. Okay? If we continue on doing this, you have a wavelet. Now discuss why when we iterate on low frequency. So that's a wavelet, dyadic wavelet. It's built on a 2-channel filter bank. And the reason why we iterate at low frequency is that in most of the practical signal, they have more energy at low frequency. So that's why we iterate at low frequency to decode it on better and better. That's a good thing. And you can iterate this, further, right? And a shorthand notation for this is basically I can do something like this, right? If I do this, you know that this is basically a 2-channel filter bank, the analysis. Right? It consists of H0, H1, and downsampling by 2. Okay? And we know how to reconstruct, right? All I can do is reconstructing this branch, and then this, and that, and that. Okay? So reconstruction is simple. Basically, this. Okay? So how does the signal look like if you do this? Let's see. Okay, good example. All right. So, can you describe for me this wall? How do you describe this wall in Vietnamese slide?
This one is on and flat.
It's kind of flat, right?
Flat.
And what color? Like yellow, white, yellow, right? Good, good. Look, can you describe me this wall?
Height about
Okay. How about some structure here?
It's line, smooth, soft.
Tuấn, can you tell me what you want? No, not Tuấn. What's your name? Then can you tell me what? Describe me this wall. Yellow, it's kind of flat. Do you see this? Do you see this? See more structure, right? Tuấn, can you put your hand in here and tell me how to describe this wall? It's not flat at all. It is very, very non-uniform, right? You have small bumps and so on and so forth. Okay? If you believe me, basically you can look at the object, right? Far away. And at this length, it's basically a yellow wall. It's flat. It's perfectly flat. Okay? At half the distance, I can see a dot right there, but it's still flat. I can see some dirty mark out there. Okay? At 1/4 of the distance, I can see more structure, right? I can see that bump actually have some direction going down, right? This line here, there's a line goes up like this, a crack, and so on. When I'm on the wall, holding, touching it, it's really, really, really non-uniform. It has small